A closed system is defined by having no external forces acting on it. So it could be one object, multiple objects, and they can apply forces to each other, but there cannot be an external force acting on them. And this comes with certain rules that always are true. For example, energy is always conserved in a closed system. So the amount of energy, if you're at a time t and then and you have X amount of energy at any other time, you'll still have X amount of energy in the system. This energy can be converted between types of energy. For example, kinetic energy and gravitational potential energy. If an object is falling, then gravitational potential energy will be converted into kinetic energy. However, it can't start with more or less energy than it ends with. And so momentum is also conserved in a closed system because there are no external forces acting on it. And this applies to both angular and linear momentum. So if we have a problem on the AP exam, which of the following properties of the two disks, so this problem refers to this situation. A solid disk of mass m and radius r is freely rotating horizontally in a counterclockwise direction with angular speed w, or about a vertical axis, through its center with negligible friction. The rotational inertia of the disk is mr squared over 2. A second identical disk is at the rest and suspended above the first disk with the centers of the two disks aligned. As shown in the figure above, there is no contact between the disks. The second disk is dropped onto the first disk, and after a short time, they rotate counterclockwise with the same angular speed of WF. So, which of the following properties of the two-disk system must be conserved between the time the second disk is dropped and on the first disk and the time the two disks begin rotating with the same speed? And there are a list of options. A, kinetic energy only. B, angular momentum only. C, both kinetic energy and angular momentum. D, neither kinetic energy nor angular momentum. And E is that it cannot be determined. So first we have to look at the system and determine if it's closed. So it is, because there are no external forces acting on it. It's only these two disks which start off being separated or rotating on the same axis and end up together rotating at the same speed on that same axis. So because it's a closed system, angular momentum will be conserved. And as far as kinetic energy goes, we have to see if there's any where this kinetic energy could be converted into potential energy in this case. So there isn't, because it's not going to gain any gravitational kinetic energy or lose any that matters for us, and it's not going to get any spring potential energy or any other form of potential energy. So both kinetic energy and angular momentum will be conserved.